Questions 11 through 20 on the 2007 Grade 12 AMC 12A. A finite sequence of three-digit integers has a property that the tens and units digit of each term are, respectively, the hundredths and tens digit of the next term, and the tens and units digit of the last term are, respectively, the hundreds and tens digit of the first term. For example, such a sequence might begin with 247, 475, 756, and end with the term 824. Let S be the sum of all the terms in the sequence. What is the largest prime that always divides S? So first, let's make this series, or sequence rather, that they give us, 247, 475, 756. Now what's happening is those two terms are now becoming those two terms. See that? And then these two terms now become those two terms. See how it shifts? So if you continue in this way, you'll be able to make a complete sequence. 5, 6, I don't know that yet. And then 6 something. And then finally 8, 2, 4. So obviously this has to be an 8 and a 2. And this has to be an 8. Right? So this meets the criteria. They just shift the terms. That's the interpretation of what they told me in the question. So, what is the question asking us? If you add all these up, what will it be divisible by? All right, well, one thing is, instead of adding it immediately like that, let's look at the terms. Since this 7 has shifted over here and then shifted again, it appears 3 times. It appears in the units digit section, the tens digit, and the hundredths digit. So if you add those, it'll be 700, this guy, it'll be 70 from this one, and it'll be 7. So that is 777, and that is basically equal to 7 times 111. And then in a very similar way, if you look at any other number, let's for example look at 6. It's here, and then it was here, and then it was here. So it also appears in the hundreds digit, in the tens digit, and the units digit. And if you add those, it will be 666, which is 6 times 111. And you can do the exact same thing for all of the other digits. So what do we have? We have 2s, 4s, 5s, and 8s, correct? So the 2s will also give 220 and 2, which is 222, which is 2 times 111. And in a very similar way, the 400s, the 5s, and all that. You get the point here. So, what's the point of doing this way? Because instead of adding it up like this, you'll get some number which will be essentially meaningless. But if you do it this way, you'll see that it actually has a certain pattern. This is 4 times 111, this is 5 times 111, and this is 8 times 111. So all of these sums, now if you add them, you'll see that 111 is the common factor, and you will just have to add what's left. So 7 plus 6 plus 2 plus 4 plus 5 plus 8. I'm not so concerned about that number, but this number is very important. That tells you that any sum of this form, 111 will be able to factor out. And what is 111? It is 3 times 37. And this will always be a factor of these sums. The larger of these primes is 37. So therefore, the answer to number 11 is D. Integers a, b, c, and d, not necessarily distinct, are chosen independently and at random from 0 to 2007 inclusive. What is the probability that AD minus BC is even? AD minus BC, we want it to be even. Well, how can that happen? Let's look at individually at both of those. It can happen if you have even minus even. That definitely equals an even. But what if I have even minus an odd, where this is even, but this is odd? Well, that equals an odd, so that's no good. What if I had odd minus even? That also equals an odd. And finally, if I have odd minus odd, that would equal an even. So the scenarios that I want are this one and this one. Okay, so how do I figure out the probability of those? Well, then I have to look at each individual term, A times D, for example. A times D is A times D in the sense that it's two numbers, and I have to do the same thing, but now I'm multiplying. So even times even, if A was even and D was even, what would that be? Well, it equals an even number. How about even times odd? That is going to be also even. Odd times even, where A is odd and D is even, that would also be even. And finally, if you have both numbers odd, and you multiply them, that would give you a result that's odd. So now let's turn our attention to the question and try to figure out the probability of this and this. Even for this and even for that. Well, the probability of getting even for AD is, of all these, it's 3 of them, 3 of the 4 possible combinations. So the probability of getting even for AD is 3 out of 4. But in addition to that, I also have to get even for BC. Even for BC will be the same probability, 3 over 4. And I have to multiply this because it's this and this. This has to be even and that has to be even. And therefore that is 9 over 16. Now turn our attention to this guy. AD has to be odd and BC has to be odd. Well, what's the probability of getting AD odd? Well, it's 1 out of the 4 scenarios, so it's 1 out of 4. And the probability of getting BC is odd. It's the same thing, 1 out of 4. And since I need that and that, you multiply. So you get 1 over 16. So you want this scenario or this scenario, so you have to add those 2 probabilities. And if you do, you get 10 over 16, which in lowest terms is 5 over 8. So number 12, the answer is E. A piece of cheese is located at 1210 in the coordinate plane. A mouse is at 4, -2 and is running up the line y equals minus 5x plus 18. At the point AB, the mouse starts getting farther from the cheese rather than closer to it. What is A plus B? So let's put this on a coordinate plane and try to understand what's happening. So first and foremost, let's label the point 1210. So approximately, say somewhere here, 1210. And that is where we have the cheese. So C for cheese. And then the mouse is at 4, -2. So approximately here. 4, -2. And that is where the mouse is. Now he is running in a direction of this line. So let's plot that line. All I'm going to do to plot that line is just get one coordinate other than the 4, -2. And I'll just use the y-intercept. So that'll make this, when x is 0, y is 18. So that makes it pretty quick. So approximately here, this is 18. And now I can join those two to get this line. So this line is something like this here. This line is represented by the equation y is equal to minus 5x plus 18. And this mouse travels along this line, obviously going in that direction. So initially he's here, and that's sort of his distance from the cheese. As he gets to here, he starts getting a little bit closer, right? But then once he gets to a certain point, he is the closest he can possibly be while remaining on that line. And that point is very important because that point represents the closest distance. So it would be a straight line that's perpendicular from C to that line, like this. Once the mouse gets to this point right here, he is at the closest distance he can be to the cheese while remaining on this line. Once he starts moving past that, he starts getting farther away. So we have to figure out the coordinates of that point, and they tell me that it's AB. All right, no problem. So how do I do that? Well, the first thing I need to do is figure out the equation of that line. Well, the equation of any line is y equals mx plus b. This line is perpendicular to that line, so its slope will be the negative reciprocal of that slope, and that is 1 over 5. Now b, of course, I have to figure out, and I can do that by substituting that point. So y is 10, x is 12, so that looks like b is equal to 38 over 5. So there we go. We just got the equation of that line. 1/5 x plus 38 over 5. And now to figure out the AB, I just have to find the intersection point of these two lines. So set them equal to each other. So minus 5x plus 8 is equal to 1 over 5x plus 38 over 5, like that. Multiply through by 5, and we'll get minus 25x plus 4 plus 90 is equal to x plus 38. And therefore, this looks like 52 is equal to 26. 52 is equal to 26x, and therefore x is equal to 2. To get y, I just substitute it back into this line, and that would give me minus 10 plus 18, and therefore y is equal to 8. And therefore this point AB is 2, 8. And what they wanted in our question is to figure out a plus b. So a plus b is equal to 2 plus 8, which is equal to 10. So number 13, the answer is B. Let a, b, c, and d, and e be distinct integers such that this expression is equal to 45. What is the value of a plus b plus c plus d plus e? So this is our expression, and the first thing, of course, I need to do is break down 45 into its prime factors, and it's going to be equal to 3 times 3 times 5. Now, there's 3 of them, and there's 5 of these numbers, so what do I do? Well, what if I add just a 1 and a 1? And then that way I can just kind of fiddle around with this. I can call this 3, 3, 5, 1, and 1. Will that be sufficient? And unfortunately, the answer is no. Why? Because of this one word right there. This would not give me distinct. A and B would end up being the same. D and E would end up being the same, namely 5, 5, 3, and 3. So, unfortunately, it's not that straightforward. Okay, so I've got to figure out a way of doing this, but not this way. So what is the solution? Well, I can still use the same numbers, but I can make 2 of them negative. If I do that, those negatives will cancel out. So for example, if I use negative 3, the 3 is fine, 5 is fine, that first one is fine, but the last one, I'll make that a negative 1. This, if you multiply it all out, does indeed equal positive 45, because this negative cancels with that negative. That way, I can make this negative 3, 3, 5, 1, and negative 1, and this will give me 5 distinct numbers for A through E. Well, let's figure this out. If 6 minus A is equal to negative 3, that basically means that A is equal to 9. All right? Then 6 minus B is 3, that means B is 3. 6 minus C is 5, that means C is 1. 6 minus D is 1, that means D is 5. And 6 minus E is negative 1, so E is 7. Are these distinct numbers? Yeah, 5 completely distinct numbers. Now we have to find their sum. So their sum will be 9 plus 3 plus 1 plus 5 plus 7. And that is 12 plus 13, 13 plus 5, 18, 18, 25. There we go. So number 14, the answer is C. The set S, or 3, 6, 9, 10, is augmented by a fifth element n, not equal to any of the other 4. The median of the resulting set is equal to its mean. What is the sum of all possible values of n? So this is going to involve casework. First and foremost, we've got these 4 numbers, and then we're going to have an n in there. So we'll make a little table here, mean and median, for certain values of n. So first, what is the mean? It's 3 plus 6 plus 9 plus 10 plus n all over 5. And that is equal to 28 plus n over 5. Now, they don't tell me if n is an integer or not. I wonder if that is a requirement. Fifth element. Well, I'm going to treat it as if it's an integer. So here we go. This is very important because that, in order for that to be an integer, this top has to be a multiple of 5. That's going to make things a little bit easier for us. So I only have to worry about n values that make that a multiple of 5. The first one, of course, being 2. If n is 2, this expression becomes 30 divided by 5, which is 6. If n is 2, let's place that somewhere. Here is my 4 numbers. N is 2, so that 2 would go here, right? If I'm writing them in order from smallest to largest. And therefore, what is my median? Median is the middle value, which is 6. So there you go. The median is equal to the mean, so I've got one value of n. So let's continue like that. For the next value of n, again, I have to make that top number divisible by 5, so I use n equals 7. And then let's just fill out all the n values. 12, 17, 22, 27, and so on. Those are the only values that are going to give me an integer for this, which represents the mean. So let's calculate the mean now. The mean when n is 7 is going to be 7. If n is 7, where does the 7 go? Well, the 7 goes right here, right? And that makes the median equal to 7. So there we go. We got another one that works. Now let's look at n equals 12. When n is 12, this becomes 8 for the mean using that formula. When n is 12, that 12 would actually go here. So that means the median is a 9. So that is 9. So unfortunately, that one doesn't work. How about n is equal to 17? If n is 17, then this mean becomes 17 plus 48 divided by 5, which is 9. And if we have n equal to 17, that goes here. That makes the median equal to 9, and that works. Now let's look at n equals 22 next. And when n is 22, the mean becomes 10. And if you put 22 in that list, the median is 9. So that doesn't work. And if you keep going like this, 27, for example, will give you a mean of 11. And if you put 27 in that list, you will see that it will give you the same mean. The mean will again be 9. So the only values of n for which the mean is equal to the median are n equals 7, n equals 17, and n equals 2. And they want you to add up the possible values of n. So those are 2 plus 7 plus 17, and that is 9 plus 17, which is 26. So number 15, the answer is E. How many three-digit numbers are composed of 3 distinct digits such that one digit is the average of the other two? So we've got A, B, and C, and the rule is A is equal to B plus C over 2, which would give me 2A is equal to B plus C. Or the rule can be that B is equal to A plus C over 2, which would give me 2B is equal to A plus C. Or C is equal to A plus B over 2, which means that 2C is equal to A plus B, like that. So those are the 3 possible ways of doing this. So let's make a table and let's see what we get. So the first scenario is the one where we have A, B, C, but 2A is equal to B plus C. All right? So if 2A is equal to B plus C, A cannot be 0 because this is a 3-digit number, so the smallest value is 1. And we just fill these in according to this equation. So 1, 2, 0, 1, 0, 2, like that, and 1, 1, 1. Okay? And at the end, I will explain this a little bit better. So first, let's just list them. And this gives me, for the ones for A, 3 possible. For 2, I get 2, 4, 0, 2, 3, 1, 2, 2, 2, 2, 1, 3, and 2, 4, 0, or 2, 0, 4, sorry. So for the 2s, I got 5. And in a very similar way, you just keep going like this. For the 3s, you'll get everything from 3, 6, 0, 3, 5, 1, and so on. And for the 3s, I got 7 of them. For the 4s, I will have a whole bunch, everything from 4, 8, 0, 4, 4, 4, all the way, dot, dot, dot. I'm not filling in all of them, all the way until 408, like this. And for the 4s, there's 9 of those. So very similarly, for the 5s, you have everything from 5, 9, 1 down to 5, 1, 9. And for those, there's 9 also. For the 6s, 6, 9, 3, all the way until 6, 3, 9. And that gives me 7. For the 7s, I have 7, 9, 5, dot, 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 until 7, 5, 9. And that gives me 5. For the 8s, we got 8, 9, 7, and 8, 8, 8, and 8, 7, 9. I'm not filling all of them, just giving you an idea there. That's 3. And finally, for the 9s, we've got just 1, 9, 9, 9. So if you add up all these, we've got 3 plus 5 plus 7 plus 9 plus 9 plus 7 plus 5 plus 3 plus 1. Now if you add those up, you get a total of 49. But there's something important that you have to read in the question. 3 distinct digits. So they cannot all be the same. So we have to eliminate any times we have 2 numbers that are the same. So there was a 1, 1, 1 there. There was a 2, 2, 2, right? We have to get rid of those. Get rid of the 3, 3, 3. Get rid of the 4, 4, 4 that I didn't write in. Get rid of the 5, 5, 5. Get rid of the 6, 6, 6. The 7, 7, 7. The 8, 8, 8. And of course this 9. So how many do I have to eliminate? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 49 minus 9, that is how many I get. For which one? For this scenario, A, B, C, when 2A is equal to B plus C. Now the good news is you don't have to do this all over again for the second scenario, this one, or the third scenario. Those will be the same, but you have to subtract a few things. ABC and ABC, this one when 2B is equal to A plus C, and this one when 2C is equal to A plus B. Now remember, for this scenario, we got 49, correct? All the way down here, and then we subtracted the 9 to get 40. So this scenario gave 40. I'll just write 40 here. But for this scenario and this scenario, it will be 40, but there's a few we have to subtract. Why? Because in this scenario, B cannot be a 0. Because if B was a 0, then that would mean that 2B is equal to A plus C, and that means 0 is equal to A plus C. And the only way that would work is if you have 0 and 0. But obviously that's not a 3-digit number. Or if you had negative, like if you had 5 minus 5, but C cannot be negative 5, right? I mean, C is an integer between, in that case, 0 to 9. So we have to eliminate all of these that have B as 0. And there's not that many of them. There's this one, 1, 2. Let's see here, another 0 somewhere. This one, 306, that I forgot to add in, that would be a 0. And then this one, 0, 8. So those 4, this one, this one, this one, and that one, we have to subtract from the 40. And that gives me 36. And the same thing with this, we can't have C equal to 0. So those ones we also have to subtract anytime there's a C equal to 0. And that would be this one, that one, this one, and this one in here. So 1, 2, 3, 4. So again, it's 40 minus 4, which is 36. So the grand total is 40 there, plus 36 plus 36. And that is 72 plus 40, which is 112. So number 16, the answer is C. Suppose that sine of A plus the sine of B is equal to the root of 5 over 3. And the cos of A plus the cos of B is equal to 1. What is the cos of A minus B? A few trigonometry laws that we will need. The first one, which I'm sure you remember, is sine of x squared plus the cos of x squared is equal to 1. But we're also going to need one that involves the cos of A minus B. And that one, specifically for A minus B, is the cos of A times the cos of B plus the sine of A times the sine of B. And I think those two should be sufficient to solve this question. So first and foremost, let's take these expressions, and I'm pretty sure we're going to have to square them. So let's do that. Let's square both sides. And I'll do the exact same for that guy right there. Cos of A plus the cos of B is equal to 1, and we'll square both sides as well. So if you do that, you get the sine of A squared plus 2 sine A sine B plus the sine of B squared. And that is equal to 5 over 3. And this one, if I do the same thing, it could be cos of A squared plus 2 cos A cos B plus the cos of B all squared, and then that is equal to 1. Now I will add them. Add both of these left side and add the right side. So if you add the left side, and I'll group them accordingly so I can take advantage of that law. Sine of A squared plus the cos of A squared, that takes care of that one and that one, plus the sine of B squared plus the cos of B squared, that takes care of that and that. And then factor out the 2, and we get cos of A cos of B plus the sine of A times the sine of B. And that equals 5 over 3 plus 1, which is 8 over 3. All right? Well, this guy right here is equal to 1. That is equal to 1. And this, all of that, is equal to the cos of A minus B. So you see how those two came in handy, those two laws. All right, we are almost done here. So I have 2 cos of A minus B is equal to 8 over 3 minus 2, like that. And that is just 2 over 3. And then if I bring the 2, it becomes like that. And then that becomes just cos of A minus B. And that's just 1/3. So there you go. Have a couple of trig laws to help us get the right answer. Number 17 is therefore B. The polynomial f at x is equal to x to the 4th plus ax to the power 3 plus bx squared plus cx plus d has real coefficients. And f at 2i is equal to f at 2 plus I is equal to 0. What is a plus b plus c plus d? If we have these roots, 2i and 2 plus I, their conjugates will also be roots. So we will have 4 roots to this polynomial, and those 4 roots are 2i and 2 plus I, which is what they gave us, and then the conjugate, which is minus 2i and 2 minus I. All right, so this is R1, R2, R3, and R4, the 4 roots of that polynomial. And therefore, f at x can be written as follows: x minus R1 times x minus R2, and so on, R3, R4. And if I substitute these values, I'll get the following. F at x is this big long polynomial right there. And I'll substitute my roots, x minus 2i, x minus 2 plus I, like that. Then x plus 2i, and then x minus 2 minus I, like that. All right, so here we go. Let's multiply. Let's multiply these two together first, because that will make it easy. X squared minus 4i squared. All right, that makes it a little bit easier. Now we've got to multiply this one and that one. So that will give me x squared minus x times 2 minus I minus x times 2 plus I. And then we've got plus 2 plus I times 2 minus I, like that. All right, so here we go. So this one, I squared is negative 1, remember? So we can put that in, negative 1. So this becomes x squared plus 4. And then we got a little bit of algebra here, and if you multiply this all out, you'll get x squared minus 2x plus ix And then let's see here, minus 2x minus xi. And then this will become 4 minus I squared. Okay, so we got x squared plus 4, x squared minus 4x. These cancel, and then I squared is negative 1, so this just becomes negative times negative 1, so 1, so that makes this 5. And then we've got to multiply this all out, and if you do, you get x to the 4th minus 4x cubed plus 9x squared minus 16x plus 20. And that is equal to x to the 4th plus ax cubed plus bx squared plus cx plus d. So now we match coefficients, and we get a is equal to negative 4, b is equal to 9, c is equal to minus 16, and d is equal to 20. And if I add all those up, the sum is 9. So the answer to number 18 is D. Triangles ABC and ADE have areas of 2007 and 7002 respectively, with B equal to 0, 0, C is 2230, D is 680, 380, and E is 689, 389. What is the sum of all possible x coordinates of A? So first, let's just draw a sketch of this graph. Put B here, and I'll put C here approximately. And then this is 2, 2, 3, 0, and this is 0, 0, like that. And then we've got E and D way out here somewhere. So D, I'll just put it here, approximately here, making that 680, 380. And then E is very close, so I'll put it here. And that's 689 and 389. And let's try to understand this question. So the first thing, of course, is they put A somewhere. Now I have no idea where that A is, so I'm just going to label some point. I'll just say A is here. And they say that they draw a triangle, ABC. So this is ABC. And they say that it has an area of 2007. Okay? So if this is the altitude, let's say, let's call that height, H for height, then that means that the area of this triangle, 1/2 base times height, is equal to 2007, which is what they tell us in the question. Now the base is just going to be from B to C, which is 223. And the height I have called H. So solving for this, we get H is equal to 18. So that means that this coordinate right here is 18. But A does not necessarily have to be there. It could be anywhere, as long as it is on the line y is equal to 18. As long as it's on that line, this will work. So for example, instead of putting the A there, if I say put the A here, it will still work. Because watch what happens when I create a triangle, ABC, A, B, and C like that. Again, the height is the same. And so is the base. So therefore, as long as the A is on this line, y is equal to 18, this will work. Now, are there any other scenarios? And the answer is yes. A could be on the other side. So for example, we put it on this side, but it could be on the other side, like this. And as you can see, this will also work. So for example, if A is anywhere on here, we can make the same sort of scenario. Okay? So that's the first thing we have to establish in this question. The next is we have to join E and D. So we can work with that distance right there. And then we have to find the equation of that line. So if this line is extended, I want to know the equation of that line. All right, that shouldn't be a problem. Line ED, first and foremost, let's find the slope. The slope is rise over run. So the rise looks like from 380 to 389, so that's 9. The run is from 680 to 689, so that's another 9. So the slope is just 1. Okay? And therefore, y is equal to mx plus b. Very quickly, we get y is equal to x plus b. And then we can substitute either of these points to get the value for b. I'll just use this one. And if I do that, I get y is 380, x is 680, plus b, and therefore b is equal to minus 300. So the equation of this line is y is equal to x minus 300. All right, so far so good. Now we have to figure out the distance of ED, this distance right here, from E to D. And we do that very simply with the distance formula. Distance, of course, we have two coordinates. So subtract the x values and we get 689 minus 680, which is 9, and square it. And then same thing with the y values. 389 minus 380 is 9. And then we have to take the square root. And if you do, that distance is 9 root 2. So I'll just put that here, 9 root 2. Now we turn our attention to this part, ADE. ADE, I have to draw in that triangle. So here's A, there's D, and that triangle right there. That triangle, they have told me, has an area of 7,002. So that means area is equal to 1/2 base times height. The area is 7,002 is equal to 1/2. The base I just figured out, ED, is 9 root 2. And the height, therefore, is h. And if I solve for h, I will get a value of 778 root 2. Now, my question is, where is h? How do I look at h in this question? Where do I draw that h? Well, to draw h, you would have to draw a perpendicular from A to this line, so something like that. This would basically represent h, right here, that red line that I just drew. And that, we know, has to be a value of 778 root 2. Now comes, in my opinion, the heart of the question with regard to understanding it. It's very important to understand the next part. These A's that I drew, this guy right here, for this triangle AED, A has to be where? That is the question. Remember, for ABC, I wrote that A can be anywhere along that line and anywhere along that line, right? And I hope you understood that. By the same kind of principle, A has to be anywhere along a line that is parallel to this line. So I will draw that in. So A can be anywhere along this line, that green line that I just drew. Because anywhere, if you put A, it will have the same altitude. So if I put A here and I drop a perpendicular, that will have the exact same length as this perpendicular. And since the base never changes, the area of that triangle will be the same. All right? Now, here's the thing. Just like how in the first triangle ABC, the parallel lines can be on either side, these parallel lines can be on either side of ED. So there we go. That's the other part of the graph where A can be. So now what? Where do I go from here? Now we know the equation of this line right here that represents the extension of ED. That equation is right here. Y is equal to x minus 300. What we have to do now is figure out the equation of these two green lines. And if we can do that, we can then find their points of intersection with these two blue lines. That would be 1, that would be 2, that would be 3, and that would be 4. And that would give us our 4 A's. Those are our 4 values for A. And then we have to just add up the x coordinates, and then we'll be done with the question. Well, this line right here is y is equal to 18. And this line right here is y is equal to negative 18. So I have to figure out the equation of this line and the equation of this line. How do I do that? Well, the equation of those two green lines is very similar to the blue line. And that blue line is this equation right here. It is basically taking this equation and translating it up a little bit to get to the green, and also taking that same and moving it down a little bit, or moving it, sideways. You understand what I'm saying? So if I can figure out how much I have to move it up and how much I can move it down, then I'm set. I can figure out the equation of those two green lines. So to do that, you have to do the following. First, drop a perpendicular from the blue line down to the green line, so like this, and then drop a vertical from the blue line down to the green line, like that. Now this is a perpendicular, so this is 90 degrees right there. And recall, this line has a slope of 1. And since this line is perpendicular, it will have a slope of negative 1. And therefore, this angle in here will be 45 degrees. Okay? And recall, we had measured the altitude or the height from there to there, and therefore that is also the same. And it's right here, 778 root 2. So that means that this distance is 778 root 2. So we can now find that distance. And that is going to be, if I call it, say, V for vertical, cos of 45 will be equal to 778 root 2 over V. And therefore V will be equal to 2 root 2 times 778 root 2, and this is going to be 1,556. So that's very helpful, because that means that we take this line ED and bring it down by 1556 to get this line, or we bring it up by 1556 to get that line. So that means those two lines have the equation as follows. Their equations will be a modification of ED, which is this equation, by 1,556 plus or minus. All right? So this one is y is equal to x minus 300 minus 1,556. And this equation is y is equal to x minus 300 plus 1,556. So we're almost done. We just have to now figure out the intersection points of this line with y equals 18 and y equals minus 18, and then the intersection of this line with y equals 18 and y equals minus 18. And then that will give us our 4 points, and we just have to then add up the x coordinates. So the first intersection is between y is equal to x minus 300 plus 1,556, and y is equal to 18, and y is equal to minus 18. And the next two A points will be the intersection of y equals x minus 300 minus 1,556 with the lines y equals 18 and y equals minus 18. All right, so here we go. Let's do the first one. 18 is equal to x minus 300 plus 1556, and therefore x is equal to minus 1238. The next one, minus 18, is equal to x minus 300 plus 1556, and that gives me x is equal to minus 1274. Now turn our attention to these ones. 18 is equal to x minus 300 minus 1556, and that gives me x is equal to 1874. And then the next one is minus 18 is equal to x minus 300 minus 1556, and that gives me x is equal to 1838. So now I have to find the sum of the x's, and that is minus 1238 minus 1274 plus 1874 plus 1838, and that is equal to 1200. And therefore, the answer to this question, number 19, is E. Corners are sliced off of a unit cube so that the 6 faces each become a regular octagon. What is the total volume of the removed tetrahedra? So we want to make this cut in a way so that it will make this a regular octagon, one face. So the cuts will be approximately like that, right? And what that does is it makes all these sides the same. And that's what they mean by a regular octagon. So we are told it's a unit cube, so that means this whole side is equal to 1. So I'll just write that here. This whole side is equal to 1. So when I made the cut, I obviously have a certain distance to keep in mind. So I'll just call that x. I don't know the distance, so I'll just label it x for now. And this will therefore be x, and that's x, and so on. Now, this distance right here, from there to there, is therefore going to be 1 minus 2x. But I don't know if that's going to be so useful at this point. Let me just work with this triangular relationship. I think that will be a little bit more helpful. So if I call this red line, which represents one of the sides of the octagon S for side, that relationship is x squared plus x squared is equal to s squared, and therefore 2x squared is equal to s squared, and therefore taking the square root, we get 2x is equal to s. So s is equal to root 2x, and since this is the same, since it's a regular octagon, all of those sides are the same as I have labeled it, that distance is also root 2x. So I think that's a little bit better. Now, this plus this plus this is equal to 1. And I can solve for x that way. Before I couldn't. So that means that x plus root 2x plus x is equal to 1 because it's a unit cube, each side is 1. So factoring for x, we get 2 plus root 2 is equal to 1, and therefore x is equal to 1 over 2 plus root 2, like that. And you can rationalize the denominator, 2 minus root 2, top and bottom, like that. And if you multiply this out, it'll be 2 minus root 2 all over 2, because it becomes 4 minus 2. And that is x. Okay. So there we go. We got our value for x. Now we have to talk about what is it that they want in the question. They want you to figure out the volume of all those tetrahedrons. When I cut this, I cut it like this, right? Approximately, and then there's going to be a cut on the other side, like that. That creates a shape called a tetrahedron, and there's going to be 8 of them. So my volume of the removed tetrahedron will be 8 times the volume of each tetrahedron, and I'll call that T. Now how do I figure out the area of a tetrahedron? Well, it's 1/3 times the area of the base of the tetrahedron times the height. So that becomes 8/3. Now, what is going to be my base and what is going to be my height? Well, my base I will represent with this section right here. This will be my base. All right? So I'll just draw that in there. So my base, if I have to figure out the area, that's pretty straightforward. It's just a triangle where I've got a length of x and a width of x, right? Those are labeled. So it's 1/2 base times height, so x times x. And then what about the height? What is the height? Well, the height is going to be from here to here. That distance right there, this guy, that is going to represent my height of this tetrahedron. And that, if you look carefully, is also equal to x, right? Because the exact same type of cut happens on the other side. So there you go. That's also x. So my volume is basically 8. Actually, I can combine that too. It'll just be 4/3 x cubed. Well, x is this, so here we go. Got to put in that big long value, 2 minus root 2 over 2, all cubed. And I'll save you the pain of listening to me go through this whole thing. If you expand this out and simplify, you will get to the following expression, 10 minus 7 root 2 over 3. So from here to here, there's obviously some algebra involved, multiplying all out, collecting like terms, that kind of stuff. So the answer to this question, number 20, is 10 minus 7 root 2 over 3, and that is B.